Welcome back. My name is Jesse Helms with Intermountain 3D, and this is the third step in the reverse engineering process of the turbo air part. In this step, we are actually going to start creating the parametric model, or an actual solid body model that we can use. Now, we're going to utilize the regions that we created from the previous step to actually extract data. So on this part, we actually have a lofted feature in this cone shape here, and what we're going to do is we're going to actually select the region groups, and we're going to use what's called a loft wizard. Again, with these region groups, this is what they are for. They are for quickly extracting geometric data. So in this loft wizard, we have the ability to start creating our sections, essentially, because it's going to create sections of 3D sketches just like you would in a regular loft. If you were creating it in a program like SolidWorks, for example, you create multiple sections, and it's going to automatically section this mesh and create those 3D sketches. We have different controls inside this lofted feature to select allowable deviation, for example. We can select the number of sections we want to go through this part, and then we can scale up the size and the overall area that the loft is going to work through. So we'll go ahead and process this, and what it's going to do is it's going to take those region groups that we selected, and it's going to create a loft. So you can see here we got an actual lofted surface at this point. Now, with this lofted surface, it actually creates a separate surface body. The actual mesh data is still there. You can see it also created 3D sketches. Now, these 3D sketches are unconstrained at this point, and then at this point we could, if we wanted to, go back in and start adding some constraints or relationships like dimensions. And in this case, we're going to go ahead and move forward, and I'm going to show you here we also have the ability to check as we go along this process deviation analysis. So I actually just ran a deviation analysis on this surface body that I created against the original mesh data, and you can see that in the green areas, obviously I'm about as exact as I can get. And so we can do this through the entire process. We can start doing deviation analysis step by step to make sure we're not getting too far off base. The next thing we can do is we can actually pull a mesh sketch from the data. So we can actually create a sketch on a plane, and we can actually essentially create a cross section of the mesh data that we can utilize to start creating a base sketch. So go ahead and start this, and you can see that it's created some polylines to reference, and then from here we're going to actually start adding in our geometry. Now I'm going to speed this up a little bit. Obviously you can see it's going pretty fast, but I just want you to see that we can start adding this geometry based on the mesh sketch data, and then we can start adding relationships like vertical, horizontal relationships and dimensioning tools. So once we have that profile, it's a completely constrained profile, just like you would do in like programs like SolidWorks or Inventor. We're going to create what's called a filled face, or we're going to create a surface. Now, with any parametric program, you can create any one object, multiple different ways. So in this process, we're doing it through a process of creating surface bodies, and then we're going to take those surface bodies, stitch them together, do some trimming tools so that we have one surface unit, and then ultimately we'll thicken the part. So right here we did a sweep feature. We were adding some fillets here, so we got a surfaced area here. So at this point, we're going to go ahead and offset or thicken this part, and we're going to actually give it some mass now. So once we do that, we'll go ahead and select which direction we want to go, the thickness of the part, and again, we got different directions we can go. We can adjust our direction, and once we hit enter here, it actually creates a thickened body. Now it's actually a solid body here. And again, we can do a deviation analysis. And now you have to take the results with a little bit of grain of salt, because this part was badly worn, bent up, so we can see that some of the areas were red where some were green. So we're going to do the same process to pick up the holes. In this case, we're creating a mesh sketch. Now we're locating the holes. We're actually applying some constraints, some relationship with dimensioning tools, and we're putting all that information in. We got extrude and cut tools just like we would in other software. Now we're creating a feature to cut this section out, an actual surface feature. Again, I'm speeding this all up so that it's not too long, but you can see the process is pretty straightforward. So we're going to use this surface to go ahead and cut this part, and you can see that relatively quickly, we've taken the mesh data and we started to create an accurate 3D model representation of the part. The original part was badly worn and beat up, but now we actually have a 3D part that, this is how it would most likely be manufactured, whether this part is stamped, formed, or possibly machined, who knows. But in this case, we're going to take this ultimate part. Now it's a nice clean flat part with hole location. We have the geometry that we wanted for the loft feature. We're going to take this part and actually convert it into STL data that we can ultimately print. Now, one of the things we can do here from this data is we also have live transfer tools in Geomagic Design X where we can start to transfer to programs like SolidWorks. There is a lot of other functions that this software can do, but it really allows you to create a parametric model that can be used as an end-user part that can be modified or ultimately printed, which we will do in the next step. Thank you again for your time, and we'll see you on the next step.